So our first real application of trigonometry is finding missing side lengths. So we're going to have a look at example A as our first look at finding missing side lengths. So in A, we want to find x centimetres. How do we do that? So we're given two pieces of information. We're told that the angle is 20 degrees, and we're also told that one of the side lengths is 5 centimetres. So just like we did when writing trig ratios, because we are going to need to write a trig ratio, let's start by naming our sides. So we know that the 5 centimetres is directly opposite the right angle, so that is the hypotenuse. And we know that x centimetres is directly opposite the 20 degrees, which makes this the opposite side. So looking at our SOHCAHTOA, we can see that for this triangle, we're going to need to use sine theta equals opposite over hypotenuse. So we've written down the ratio that we're going to use. The next step is to fill in what we do know. Okay, so we're told that the angle we're looking for or working with is 20 degrees. So instead of theta, we can write sine 20 equals opposite. Our opposite is x divided by the hypotenuse, which is 5. So that's our third step done. So our first step was naming the sides, our second step was selecting and writing the ratio, and our third step was filling in the unknowns. Our fourth step is to rearrange and solve. So we want to get x by itself, just like we do when we do anything with algebra. So if we just have a look at the right-hand side, it reads x divided by 5. We know from algebra that to undo a divide, we need to times. So to take the 5 to the other side, we're going to multiply it. So it's going to be 5 times sine 20 equals x. I'm going to pop that straight onto my calculator, and I'm going to round it to 2 decimal places. So x is equal to 1.71 centimetres. That is that question complete. So now let's have a look at B. Same thing, we're going to start by labelling our sides. So we know that 20 is directly opposite the right angle, which makes it the hypotenuse. And x centimetres is next to the 60 degrees, which makes it the adjacent side. If I scroll back up to see our SOHCAHTOA, we can tell because we have adjacent and hypotenuse that we need to use cos theta. So cos theta is equal adjacent over hypotenuse. So that's step 1 and 2 done. Step 3 is to fill in what we know. So our angle is 60, so cos 60 is equal to, the adjacent side is x, divided by the hypotenuse, which is 20. Again, if it's divide on the right, to take it over to the left-hand side, we need to times it. So 20 by cos 60 equals x, pop that straight onto the calculator, and we get 10 centimetres. So that's A and B done. C is slightly different, and we'll have a look why in a moment. So let's do what we always do, start by naming our sides. 4 metres is directly opposite the 15 degrees, which makes it opposite, and the x metres is right next to the angle, which makes it the adjacent. So if we go and have a look at SOHCAHTOA, we know that we're going to be using tan. So let's write tan theta equals opposite over adjacent. Step 1 and 2 are done. Step 3, fill in the unknowns. Tan 15 equals opposite, which is 4, divided by x. So this is where the difference is. In A and B, x was in the numerator, but in C, x is in the denominator, which makes it slightly more difficult because we can't just move x to the other side to get it by itself. But let's go one step at a time. To get x from the denominator, because it's 4 divided by x, we would multiply it on the other side. So x times tan 15 equals 4. That's our next line. How would we undo a times? To get x by itself, we would divide. So to get x by itself, we're going to divide both sides by tan 15. So 4 divided by tan 15 is equal to x. Pop that on the calculator, and x is equal to 14.93 centimeters. Remembering to round to 2 decimal places because we're dealing with measurement.